Today I'm going to talk about how you identify the number of solutions in an equation. When we are identifying the number of solutions, there are three different scenarios that we could have. There's the scenario of one solution. This solution we have actually seen a lot, and you may not really realize it at the time, but that's something where you get something like x equals 4, x equals 7, x equals 999. Something where x has a 1 value. You figure out what x is equal to, and that's it. There's only one solution to that. The next possible scenario that you could come across is infinitely many solutions. So you have infinite solutions that could possibly go into this equation. You could plug in any number to the equation and it'll give you a true statement. This is where you get something, after you solve the equation, you get something like 9 equals 9, or 1,000 equals 1,000, 0 equals 0. These are all true statements. Yes, 9 is equal to 9, 1,000 is equal to 1,000, 0 is equal to 0. These are all true, and if you ever solve an equation and get something that is a true statement with no variables in it, then you know you have infinitely many solutions. The last possible scenario is no solutions. So nothing that you plug into the equation will ever work. And this is if you get a false statement. So in this case, like 0 equals 9, 10 equals 1, something like that, where you have two things that the equation says they're equal, but they're actually not equal to each other. 0 will never be equal to 9, 10 will never be equal to 1. So that is a false statement, which means that you will never have a solution to the equation. We have seen a lot of one solution. That's what you're going to see the most frequently is you solve an equation, you figure out what the variable is equal to. Let's take a look at some examples where we have infinitely many solutions or no solutions at all, and how that is going to look when we solve them. Starting with this first example, what I want to do is I just want to go ahead and solve this equation because you never know how many solutions there are just by looking at the original equation. You have to go ahead and solve it like you would, like we have been doing, and then see which of those three scenarios that we just talked about, see which one we end up getting. So if I were to solve this equation, I would start distributing. So 3 times 5x is 15x. 3 times 2 is 6. And then we want to separate the variables from the constant terms. So what I'm going to do, since there is no constant term over here, I'm going to subtract this 15x from both sides to try and get the x variables all on the right-hand side. What you'll notice, though, is the 15x cancels here, because 15x minus 15x is 0. That'll leave us with a 6. And then they also cancel over here. 15x minus 15x is 0. So we get something that is 6 equals 0. This is not a true statement. 6 will never be equal to 0. So the actual answer to this equation is not this 6 equals 0. It's actually no solution. You do want to make sure that when you're completing these problems, you either get x equals a number, you write no solution, or you write infinitely many solutions. That is the one thing that I do tend to see a lot, is someone will just say 6 is equal to 0, and that doesn't tell me anything. That doesn't tell me if that's what you think the answer is, or if it has infinitely many solutions. So just make sure that if you do get this scenario where you have a false statement, you actually write no solution at the end. All right, moving on to our next example, we're going to do the same thing that we have been doing. We're just going to go ahead and start solving the equation. So to do that, we want to get rid of our grouping symbols. So we have negative 2 times 4y, which is negative 8y, and negative 2 times positive 1. Everything else will stay the same here. If you notice this from the beginning, great. If you want to keep going, that's totally fine. But notice we have negative 8y minus 2 on the left-hand side and negative 8y minus 2 on the right-hand side. We have the same exact thing. So because we have the same exact thing on the left-hand and right-hand side, the equation will always be true. But let's kind of go deeper into that, just in case, because you won't always notice it right away. So let's go a little bit further. To move our variables around, we could add y, 8y, to both sides. And these will cancel out on both sides because negative 8y plus 8y is 0. And we'll get negative 2 equals negative 2. So even if you didn't see it right there where you had two sides that were the exact same, right here this says, well, negative 2 is equal to negative 2. Yes, we know that is true. That's a true statement. All of our variables went away. So that tells us that we have infinitely many solutions. So you could write infinite solutions, infinitely many solutions, however you want to do that. But again, just like I said in the last example, with my students, if they just gave me negative 2 equals negative 2, that doesn't tell me what you know. That doesn't tell me that you know there are infinitely many solutions to the equation. So make sure, again, that you write infinitely many solutions at the bottom there so that I know that you know that there's infinite solutions there. And that is how you can identify the number of solutions. We just want to remember we either have one solution where it's just x equals a number or r equals a number, or whatever variable there is. Or you could have the solution where you get a true statement. That's always true. 0 equals 0, 5 equals 5, something like that, where we get infinitely many solutions. Then for our last scenario that we could have, you get a false statement, something that's not true, like 0 equals 7. 0 will never equal 7, which means that we don't have a solution for that equation. And that's how you identify the number of solutions in an equation.